Hello, Algebra 1 classes. Mr. Martin here from my kids' playroom again. Obviously, I started doing these videos last week, and I hope that you're enjoying them. You're being able to see someone, a face that you know teach you math, rather than me trying to find other videos of other people teach you math. So hopefully these are helping. Hopefully they're helping engage you a little more. If you have any questions, comments, concerns, always let me know. I'd love to hear from you. Let me see, for this week, just kind of looking at the week, what this entails. Today, Monday, and Tuesday, I'm going to have videos put out for you during those days. I want you to watch those videos. And then in Canvas, you can go in and there's a discussion board and you can write comments, questions, concerns about the videos or stuff that you found difficult, stuff that you didn't understand, and we can go back and forth in there on what you need, what's confusing you, or you can email me. Obviously, I'm always in front of my email. You can email me. I'll get back to you with whatever you need. So Monday, Tuesday, you'll get videos. You can do that. There's also a work packet that goes along with these videos. So take your time to work through that. If you're not commenting on them, if you're not commenting on them in the discussion board and send me emails back and forth about them, please work on the work packet. On Wednesday, you will all be working on the work packet and then submit that on Friday or Wednesday. You can submit it on Wednesday also. But and then on Thursday is going to be a makeup day where you can get any work that you missed throughout this week, throughout last week, throughout the last couple weeks to make up. If you need to know what you need to make up, please email me. I will let you know. I have it all down. So, and then Friday is our social emotional day where you can meet with your social worker, you can meet with your behavior specialist, you can meet with any of the teachers. We'd love to hear from you. We want to hear what you're doing. It doesn't have to be strictly academics. It can be anything that's going on with you. So please reach out. We'd love to see you during those days. I know our social workers and behavior specialists are doing some groups, so reach out to them. I think 2, 3, 4 people have been showing up in them, so it's not just a one-on-one thing, it's a group thing. You get to see some of your peers that maybe you haven't seen in a while. All right, so to math, kind of what we're doing today, or what we're doing this week. We're going to be solving systems using elimination. We used substitution last week to solve systems. We're moving to elimination. Different method. I find it maybe a little bit easier if things set up correctly. So let's talk about how this works. So over here on the right side, I wrote down the steps that we need to do to solve a system using elimination. So step 1 is stack the variables in columns. Step 2 is check for opposites of the same variable. Step 3 is create an addition problem by combining like terms. And step 4 is solving for x and y. Now, what do these all mean? Let's go over them slowly now. Over here, I have 2 equations here. ax plus by equals c, and ax plus by equals c. All right, that's my system. Obviously, it's just in formula form. It's not actually in numerical form. This is how I want my equations to look when I solve them using elimination, meaning that my x values right here, my x and my x, are stacked over each other, okay? And then my y and my y values are stacked over each other, and they all equal your constant values, which are stacked over each other, okay? Because when I do this and I have opposites of the same variable, if I have a negative a and a positive a here, I just put a line underneath and then I combine my like terms just like an addition problem. All right, so now let's take a look at an actual problem to solve using elimination. So, first problem I have is 3x plus 7y equals 19. And then the second equation is negative 3x plus 2y equals negative 10. So here we go. We have 3x plus 7y equals 19 and negative 3x plus 2y equals negative 10. I take a look and I say, all right, my x values are all stacked. We have 3x and negative 3x. My y values are stacked over here. I have 7y and 2y. And then my constants, my whole numbers or my numbers are stacked on the other side, 19 and negative 10. Awesome. That means I can go right into elimination as long, or back up. Now I need to check for opposites of the same number. And then I say, start with my x value. Then I say I have a 3x here and a negative 3x here. 3x and negative 3x are opposites of each other. So that tells me I have opposites of the same number. Now I can go ahead and create an addition problem by combining like terms. I just put a line underneath and I treat this whole, both of these equations, like an addition problem. And I just add my x values. 3x minus 3x is going to give me 0x, which means those cancel out. Great. And I'm left with 7y. I have a positive 7y and a positive 2y, so I just add those together. So I have 9y equal, that's a y, equals, and then 19 minus 10. So I have a 19 and a negative 10, so I do 19 minus 10, and that just gives me 9. Now I have a very simple algebraic problem where it's 9y equals 9. And I just go ahead and I divide both sides by 9, okay? And so we know 9 divided by 9, y is going to equal 1, all right? Great. Just about done. As we did with substitution, we're going to plug this back into one of the equations and solve for the other variable. So I'm going to plug in my 1 for y, and I'm going to plug it into the top equation. So I have, we're just going to point it over here. So I have 3x plus 7 times 1 equals 19. All right, and I solve this just the same way I did earlier. And I say, all right, so 3x plus 7, because 7 times 1 is 7, equals 19. And then I'm going to subtract 7 from both sides, minus 7, minus 7, and I'm left with 3x is equal to 12. And now just divide by 3 on both sides. Divide by 3, divide by 3, x is equal to 4. So here we go. Here are my two answers. Y equals 1, x equals 4, or 4, 1 in ordered pair. All right? That's solving using elimination. Everything was stacked up. I had numbers that canceled right away so I could get rid of it. I didn't have to rearrange anything, and then I just solved. I stacked them up, I eliminated my x's, and I solved. Plugged it back in, and I solved. All right, found my x and my y variables. Okay, now let's try one more problem. But let's look at a problem that's not quite stacked up. All right, that's a little bit more difficult, where I have to rearrange the problem and then solve for my variables. Okay, give me 1 second as I just erase. (5y) minus 2x equals 3. And then negative 5y equals negative 4x plus 9. Negative 5y equals negative 4x plus 9. All right, these are my two equations now. I want to solve using elimination again because I don't have an x equals or a y equals. I have numbers in front of them, and it doesn't make it kind of pretty, for lack of a better term, to solve for the y variable or the x variable. So I'm going to go ahead, I'm going to use elimination, but I know when I use elimination, I have to have my x numbers stacked, I have to have my y numbers stacked, and it has to equal my c's, okay? This second equation doesn't have that, Okay, this second equation is a little different, so I have to rearrange the equations to make it fit what I need. So I got to get this x to the other side of the equation so that it's negative 5y, my x value equals my constant, which is 9. So what I'm going to do here is I'm just going to add 4x to both sides of the equation. Because if I add 4x to both sides of the equation, that'll get it to the other side. So here we go. I'm just dealing with this one equation, or let me write it down. Let me write it over here. So I have negative 5y equals negative 4x plus 9. And I'm going to add 4x here. And I'm going to add 4x here. So my new equation is, it cancels out on this side. Negative 5y plus 4x equals 9. Awesome. I have my y value, I have my x value, I have my constant, equals my constant. So I'm going to come on over here, and it's the same equation. It's just now written in that form. And we'll erase this, and I'm just going to put the other equation right in there. Negative 5y plus 4x plus 4x equals 9. All right. And now I can go ahead and I can eliminate. Well, first I want to make sure I have opposites of the same variable. I do. I have a 5y and a negative 5y. So that tells me right there that my y's are going to cancel. So I'm just going to cancel these, going to put a little cross through them, and I'm left with negative 2x plus 4x is going to give me 2x equals 9 and 3, both positive, so I add those together. That's going to give me 12. And then as I know, to solve 2x equals 12, divide by 2, divide by 2, I have x equals 6. Great. I know what my x equals. I bring it back up here, up to one of the equations. I plug it in. I find what y equals. I'm just going to plug it into the first equation. 5y minus 2 times 6, which is my x value, right? We'll plug that in, equals 3. So 5y minus 2 times 6 is 12, equals 3. Solve. Plus 12 plus 12, 5y equals 15. Now divide by 5, and I divide by 5, y is equal to 3. Okay? So I have my x value of 6, my y value of 3, or 6, 3 as an ordered pair. And that's elimination when our variables aren't stacked over one another. We have to rearrange one of the equations to get it to what we need. All right? I hope this helped. I'll give you a second to take a look at it. Remember, in the discussion page on Canvas, please write a few comments. Let me know how things are going. If you're having trouble with this, if you're finding it difficult to follow along online, on the whiteboard, let me know, okay? I hope all is well, and I will, in next video, what we're gonna be doing is we're gonna be taking a look at when the variables are not opposite values, okay? So we're gonna be doing a little bit more math. We're gonna take a look at that, but that's for tomorrow. Thank you.